Okay, so here we are. We're gonna, like I said, we're gonna backtrack a little bit. So let's go ahead and read these instructions up here at the top. It tells us that graphing a linear inequality is a way to show all of the possible solutions to the inequality. So remember when we wrote our answers, a lot of times it would be like, we would talk about how it's an entire range of answers. There's an interval there. And so this way we can show all the possible solutions for infinity rather than just a few select points. So graphing a system of linear inequalities is a way to show the possible solutions that satisfy all of the conditions. So it's all of the solutions that are for those specific conditions that we're going to be working with. Okay, so it's more than just one possible answer when we're dealing with a system of inequalities. So how to graph a linear inequality. Here are the steps. Step 1, you're going to put the inequality in slope-intercept form, same as when we dealt with our systems of equations, when we dealt with just linear equations. So also don't forget, this right here is important, to flip the inequality symbol if you multiply or divide by a negative number. That has not changed. Anytime we do that with an inequality, we need to do that. Okay, so just don't forget. All right, then you're going to graph the line. Okay, so if you're dealing with an equal to, less than or greater than or equal to, we're going to use a solid line. Just like before we talked about open circles versus closed circles, well, the way to show that with a linear inequality is by using a solid line. Without the equal sign, you use a dotted line, a dashed line, basically. So solid line versus dashed here. Okay? And then you're going to shade the graph. So if it's greater than or equal to, we're going to shade above. If it is less than or equal to, you're going to shade below. Okay? So up above versus down below. All right? So if that were your line, up above that, or not a very good one, sorry, or down, did that one backwards, I apologize, or down below, okay? So up above or down below. All right, when you shade a system of inequalities, the solution, okay, so this is just for linear inequalities. When we do a system of inequalities, the solution will be the overlapping area of points. It's where we cross those, okay? So before we get into practicing with systems of inequalities, we're just going to practice a few that are just linear inequalities, so just one of them, okay? So we're going to do the same rules, everything that we did before with slope-intercept. So first off, we start with our y-intercept. This is already in slope-intercept form, so y-intercept here is -5. So we're going to start at point 0, -5. And then our slope is going to be a 1/3, a rise over run. So we're going to start with 0, -5. And then we're going to rise 1 and run 3. Rise 1 and run 3. And continue that. And then we can go the same going in the opposite direction. Okay? Now, notice that our symbol here does not have an equal to, so we're going to be using a dotted line. So when we go to connect these, I'm going to connect using a dashed line here, okay? And it's greater than, and so since it is greater than, we're going to shade above that line. And so what I'm going to do is just lightly with a pencil, when you do yours, shade above that line. That means that, yes, this line continues forever, out in this direction, out this direction. It means that all of these solutions, everything that's shaded in, everything that would be shaded in if this graph kept going forever, would also be a part of the solution. But the line itself is not part of the solution because the line itself is not an equal to. Okay? So we're going to continue. I'm going to do a couple more examples to show you what this looks like. So here, same thing. We're going to start with our y-intercept. In this case, it is -1, so 0, -1 is our starting point. That's where our first dot is going to go. And then our slope here is this number right here, -2. We write that as -2/1. so that we can do rise over run. So that means we're going to go -2, 1, -2, 1, 1, -2, and 1. And then we're going to continue that pattern on from there. Okay. Notice that we do have an equal to this time, so we are going to use a solid line, and it's less than, so we are going to shade below the line. Okay, meaning that all solutions, if this line keeps going out forever, all of the solutions below that are going to be part of it, and any number that falls on the line will also be a solution that would work. And so what you need to keep in mind here is that when we start talking about this, if you need to check yourself, just pick a point out here somewhere. So for example, like choose -2, -2. I can plug in -2 for x and -2 for y, solve it, and if everything works and this comes out to be a true solution, then you know that you shaded the right area. Okay, so that's a good checking point for you. All right, 2 more examples here, and then we will move on. So this one, we do have to put this in slope-intercept form first. So I've got to get y by itself. So I need to subtract the 5x to do that. Okay, notice that I go ahead and just keep that x first, the x variable, and then everything else out past it so that I can keep it in that form. And then I'm going to divide by -2. Now I divided by a negative, so I do have to flip the sign from greater than to less than. -5 divided by -2 is going to be 5/2, and 12 divided by -2 is -6. Okay, so that means that my y-intercept is going to be -6. So 0, -6 is my starting point. And then my slope here is already written as a fraction. It's already here as 5/2. So that means I'm going to go up 5/2 over 2 and over 2. Okay. Now look, there's no equal sign, so it is going to be a dashed line. And it's everything less than that, so I am going to shade below this line. All right. All right, so that takes care of that one, and now we have one more. So on this one, I'm going to get y by itself again, so I'm going to have -4y is less than -x plus 8. Then I'm going to divide by -4. And when I divide by that negative, remember I flipped that sign again. And so I'm going to flip it, and now I have -1 over -4, which is +1/4 x, and 8 divided by -4, which is -2. And so my y-intercept here is going to be -2. So 0, -2 is going to be my starting point. Okay. And then my slope is going to be 1/4. So I'm going to be going up and over 4. And then I can go in the opposite direction as well to get a good line here. And now there is no equal to, so again we're going to be doing a dashed line. And we're going to be shading above that line. It is greater than that, so we are going to shade above it. Okay? And so again, you can just kind of check yourself and make sure that it works. So 0, 0 should be a solution that works. So x minus 4y is less than 8. We could plug in 0, and 0 minus 0 is 0. And that's less than 8, so that works. So yes, we did shade the correct area on this one. Okay, so that's just linear inequalities. So I'm going to pause this video. We'll start a new one, and we'll do a couple of examples of a system of inequalities so that you can see how that works as well. But it's going to be the same basic steps.